Everything is already rational, factored, and I have 0 on one side, table. And the ratio. Good. Which numbers will you put in the table? In the x values. Which numbers? Which x values?
2 and 4.
2 and 4, indeed. This is 0 when x is 2, and this is 0 when x is 4. This is 0 here. This is 0 here. Good. So what happens with the ratio when x is 2? What happens with the ratio when x is 4?
They're both 0.
Careful. A fraction is 0 only when the top is 0. So what happens at 2? What happens at 2? Please, anybody? We just said that a fraction is 0 when the top is 0. A fraction is undefined when the bottom is 0.
When it's 2, it's 0.
Yes. And when it's 4?
It's undefined.
That's it. Good. The sign for this. If it's this, I have to write minus and plus. If it's this, I have to write plus and minus.
It'll be plus to minus.
Very good. And what about this?
Minus the plus.
That's it. I divide the positive and the negative. I divide two negatives. I divide a negative and a positive. Finally, what am I after? Well, this time I'm after positive. Is this positive? I'm looking for positive. Positive. Yes, positive. 2 to 4. Both equal the equal symbol is included. I can include 2, but I cannot include 4 because it's undefined. So I'll say x in the interval closed at 2, but open at 4. So bracket and parenthesis because 4 cannot be included. The expression or the fraction is undefined. Okay? Let's choose. Anybody?
Can we do 54?
Yes, 54. In 54 we have x plus 3, x minus 2 over x plus 1 less than or equal to 0. All nice. So these are the most difficult ones. So we're going to choose from here in a minute. All these are nice because the left-hand side is factored, the right-hand side is 0. But here's a different story. More work is required before I bring all these to this setup. A ratio factored on the left and 0 on the right. So it's a good warm-up. Of course, nice and easy because everything is factored. X is the variable in the problem. X plus 3 is the first factor. X minus 2 is the second factor. X plus 1 is the third factor. And the last, what I'm interested in, is the whole thing. which values will you put, x values will you put in the table, and what is the correct order?
It would be -3, -1, and 2.
Excellent. -3, -1, and 2. This 0 under -3, this 0 under +2, this 0 under -1. Now I have to establish what happens to the ratio at those points.
That one will be 0.
Indeed, because the numerator is 0. -1.
Undefined.
Yes, because the denominator is 0. And at 2,
0.
yes, indeed, because the numerator is 0. All these have the same sign because they all have a positive leading coefficient, or in other words, a positive slope. They're all like this. I don't have to think. Nothing against thinking, but what I'm saying is it's very easy. 3 negatives,
Negative,
2 negatives,
positive,
1 negative, no negatives. What am I after? Again, I'm after negative. Aha. Aha. Not -1, but the equal symbol. Negative infinity, -3 closed. Union, -1 not closed, but 2 closed. So x in this interval. Okay, let's take a look at one of those more sophisticated ones. Nothing difficult, but let's choose one of those so we can see what's happening there, because they are not set up for the table. We need work. We need to work a little bit to set them up correctly. Which one?
Can we do 58?
Yes. 58. 58 has 1 over x minus 3 less than 1. The table cannot be used unless the left-hand side is completely factored, product or quotient, and the other side is 0, because we're comparing only signs. So first I have to move 1 to the other side. 1 over x minus 3 minus 1 less than 0. Now I have the 0, but this is not factored yet. So I have to find the LCD, and then it will be ready for the table. Initially, it was not ready. So what is the least common denominator? And you can say there is only one, just copy it, right? There is only one, it's x minus 3. But what do I need to multiply -1 by and write it up here? What do we multiply -1 by?
Would you multiply it by x minus 3?
Of course. So I have 1 minus x plus 3. So the numerator is -x plus 4. The denominator is x minus 3. and I'm done. It's not solved, but I changed it from something that I could not solve into something I can solve, because this is table ready. This is not table ready. The table requires 0 on either side and the product or a ratio completely factored on the other. Now I got it. It wasn't. With a little bit of algebra, I was able to get it into the format that allows me to solve it. So now, that's it. Table, and it's done. So x is the variable in the problem. Negative x plus 4, x minus 3, negative infinity to infinity, and of course, negative x plus 4 over x minus 3. Which numbers or which x values go into the table?
3 and 4.
Very good. In that correct order. This is 0 at 3. This is 0 at 4. Now I need to know what happens here. And then I fill in the signs and I'm done.
3 will be undefined.
Yes, of course. And 4 will be 0. Excellent. The signs, the sequence of signs for this, the sequence, the signs for that.
Plus to negative.
Yes. And this is the regular one. I divide a positive by a positive by a positive, a negative by a positive. Only now I look back to see what I am looking for. Again, which sign is less than 0? Okay, it's negative. So this is what I need to choose. But I cannot choose 3. And I cannot choose 4 because there is no equal symbol anyway. So negative infinity to 3, union 4 to infinity. X in this interval. So this one wasn't a chart or table ready. A little bit of algebra moving and finding the least common denominator brought us to what we needed. And then the table followed quickly. Any questions? This is the end of chapter 3. Now, we have 15 minutes, roughly 15 minutes left. What would you like us to go back to from chapter 3? Let's make a list, first of all, of what to expect. And then you will tell me what you would like us to continue with. Okay, so here is the table of contents, if you want, of this upcoming test. So number 1, quadratic function, graph, and word problems. This is going to be a very short test. Number 2, cubic, 4th degree, polynomial functions, graph. Number 3, rational functions, graph, word problems. And number 4, polynomial, poly plus rational inequalities. That's it. Division. Division of polynomials. That's it. There's nothing else. I'm looking at the book. I'm flipping through the pages. Polynomial, rational functions, and their graphs. Of course, the division, including the theorems, the two theorems, right? The remainder and the remainder and the factor theorem.
When is the test again?
Say it again.
When the test again, just to be sure.
When is the test? You're saying?
Yes.
Two
Yes, ma'am.
2 weeks from today.
Okay.
That's it. Because we have the 20 and the 22nd and the 27th, I will not be able to use 3 sessions to review. I have to start chapter 4. So we have the 20th, the 22nd, and the 27th. So I have no choice, but I have to start chapter 4 sometime. So I think it's up to you. We start chapter 4 and then we review, or we review and then we start chapter 4.
Our chapter 4 now.
Chapter 4 is not part of this test, but I can't use 3 sessions to review. Because we still have chapter 4. Let me look just 1 second. We still have chapter 4. We have a little bit of chapter 5, we have a little bit of chapter 6, and we have chapter 8 left. So we still have a lot to go. So we have chapter 4, 5 sections. We have chapter 5, 4 sections. We have chapter 6. Okay. So 5 sections plus 4 sections, that's 9, 10, 11. Okay. So from all these, what would you like to continue with now? What would you like to go back to? What would you like to review? We still have few minutes left. I know you're tired. I know it's a long class. Let's work on something. Let's review anything.
Can we do the rational functions?
Yes, to graph.
Yes.
Yes, you choose what type. So let me open. Where are the rationals? I'm looking for the page. Page. Flipping pages. 429. Choose anything you want. Any function. Good. Which function would you like to work on?
We do 78.
78, very good. Let's continue with 78. 78 on 429. 78. So f of x equals x squared divided by x squared plus x minus 6. Perfect pick. Let's do that. Good. Of course, we have to factor the denominator immediately. for many, many, many reasons. And one of them is the domain. What would be the domain after we factor? Can anyone factor x squared plus x minus? We
and
had,
then
yes.
zero.
I couldn't hear you, but I think you said x plus 3x minus 2. We already did this factor. Okay, so the function, the fraction is undefined when? It's undefined at? Anyone, please?
So it can't be -3 and it can't be 2.
Very good. Those factors don't disappear. Can anyone give us the horizontal asymptote and the type? What type is this? Type? Is it type 1 or type 2?
Two.
It's type 1 because it's the same degree over same degree. So it is type 1. And then what would be the horizontal asymptote if it's type 1?
0.
For
Y.
type, yes, the
Oh.
leading coefficient over the leading coefficient. So y equals 1, horizontal asymptote. Good. These are vertical asymptotes, so I know what's happening there, but I don't know the sign. So I will be using -3.1 and -2.9. I will be using 1.9 and 2.1. Very easy situation because the numerator is always positive. Don't even bother with it. No need. It's always positive. So with -3.1, negative, negative. With -2.9, positive but negative. With 1.9, positive but negative. And with 2.1, positive and positive. Don't bother to waste your time with the numerator. It's always positive. It's not going to have any influence. So plug in 0 and tell me what you get. F of 0 is? F of 0 equals?
Is it just 0?
Yes, 0 over -6 is 0, indeed. Done. Ready? When we graph a function with asymptotes, we have to graph the asymptotes first. They are not part of the graph, but they have to be graphed. So this is y equals 1, -3, and +2. Ready. We read the table. From 1 up to infinity. Easy. From -infinity up to 0, down to -infinity. I don't know if it turns at 0. But actually, you cannot cross. Yeah. So this time it has to turn at 0 because it doesn't have any other x-intercept. And then from +infinity to 1. Easy. This is the graph of f of x equals x squared over x squared plus x minus 6. With the graphing calculator. We go back and check with y equals, clear everything. Remember to enter a secondary function, the horizontal asymptote y equals 1. So the top is x squared. It doesn't need parentheses, but the denominator does. X squared plus x minus 6. I'm pretty sure that the standard viewing window is a good choice. As expected, from positive 1 up to infinity, from negative infinity turns at the origin, going back down to negative infinity, from positive infinity getting closer and closer to 1. Exactly as expected. Any questions? Okay, back to our list. Back to our list. What would you like to choose next? We still have a few more minutes.
Can we do a synthetic division problem?
Yes, of course. Do you want to choose or you want me to make one up?
Can you make one? I don't have it open.
Yes. Yes. Well, let's say x to the third plus x minus 2 divided by x plus 2. What goes in the box?
Is it -2?
Indeed. Now I have to be very careful now. The degree is 3. The leading coefficient is 1, but degree 2 is missing. Degree 1 has coefficient 1, and degree 0 has -2. I always bring down the first coefficient, no matter what it is. -2 times 1, -2. Perform the operations I see. -2 times -2, right above the line. Add. -2 times 5 is -10. And the box has -12. I divided degree 3 by degree 1. What is all this? What is this? X to which power?
X squared?
Yes. And this one is minus 2x, and this is plus 5, and this is minus 12 over x plus 2. Question: how can I find the remainder of this division without looking at the quotient? How can I find the remainder of this division quickly? So the numerator, I'm going to call it p of x equals x to the third plus x minus 2. How do I find the remainder? I know it's 12, -12. I want to check. And how do I find the remainder? What do I need to do? Plug -2 in the polynomial here. If this answer is not -12, something is wrong. Negative 2 to the third is negative 8. Negative 2 minus 2 is indeed negative 12. So I use the remainder theorem that states the remainder of this division is the polynomial from the numerator evaluated at negative 2. And it is.